Teacher time. Okay, so again, we just started. Midpoint, as Catherine just eloquently told me, is one point that divides the line into two equal parts. So for example, point X is the midpoint of AB. So I'm gonna come over here, and if this was not already marked, I would mark it. I would show that AX and BX are both congruent marks. Point Y is also a midpoint. It says point Y is the midpoint of BC. So point Y is also a midpoint where BY and YC are congruent to each other. So we've already known about midpoints. The new thing I'm teaching you today is a midsegment is where you connect two midpoints. So a midsegment is the segment XY that is formed by two midpoints. It's formed by connecting two midpoints. So definition, connecting the midpoints of two sides of a triangle creates a segment called the midsegment of the triangle. Midsegment is made up of midpoints. So mid and mid go together in my head. Every triangle is going to have a total of 3 midsegments. I only have one drawn, but I can draw another one. Let's see if I draw the midpoint for AC. Let's say that's right about here. That is congruent to that. Maybe we'll call that Z. XY was a midsegment. XZ is a midsegment. And YZ is a midsegment. So every triangle has a total of 3 midsegments inside. All right, everyone hanging in there so far? Okay, midsegments are made up of 2 midpoints, midsegment, midpoint, midsegment, midpoint. All right, there's some special relationships between midsegments and then the side opposite them. So I just copy and pasted this picture down here just so we can look at it again. There are 2 things that are special about XY and AC. Okay, one thing, what do these little lines mean? What do these little arrows mean right there? Parallel. So the midsegment is parallel to the side opposite. So the midsegment is parallel to the third side of the triangle. Okay, that's cool. Now the length of the midsegment, this is special, and I don't think we would know this without me telling you. The length of the midsegment is half of the length of the third side. So like, let's say XY was 2. That is half of the segment AC. So AC would be like 4. And you can go one way or the other. You can think about going from 4 to 2 or from 2 to 4. So we'll talk about that. So this is kind of like my SparkNotes version of what's going on. XY is parallel to AC. So the midsegment is parallel to the third side. And the midsegment is equal to half of the third side. XY equals 1/2 of AC. Now, we haven't done math for like 5 weeks. Who already hates fractions? Right? And I just gave you a formula with a fraction in it. How can we rearrange it so there's no fraction in that? Good. I'm going to multiply by 2 on both sides. So I can think of this instead of being XY equals 1/2 AC. I can think of it as 2 times XY equals AC. Those are both the same. So if you'd rather think of it 2 times the midsegment equals the third side, that's okay with me. All right, now we're going to do some problems. We've got basically the exact same diagram. We're just answering these little questions about it. You guys ready? Okay. How do we know that XY, YZ, and XZ are all midsegments? How do I know those are all midsegments? That's not it. That's true. That's not why we know. Why do we know that those are midsegments? Yeah, Chris? The lines on either side of them are congruent. So that makes point X what? A midpoint, and that makes point Y a midpoint, and that makes point Z a midpoint. Very good. So because we know that because we see the congruent marks, we know that they are midpoints. So I'm going to write X, Y, Z are midpoints. And we know that they're midpoints by the congruent marks. So we know XY, YZ, and ZX are all midsegments because they're made up of midpoints. Okay. What about how is XY related to AC? How is XY related to AC? We know two ways that they're related. Who can give me one? Ella? Good. So XY equals half of AC. Rosie, you got the other one? That is also true. It's the exact same thing that we wrote, so I'm not going to rewrite it. Jack? They are parallel. Very good. XY is parallel to AC. Yeah, those are two things we literally just learned, right? Okay. Now it says, how is XZ related to BY and CY? Let's look at those. How is XZ related to BY and CY? First, tell me, how are BY and CY related?
They're equal segments.
They're equal, they're congruent segments, good. And then what about XZ?
It's half of the.
Good. Catherine says it's half of BC. What also is half of BC? BY and good. So all three of those segments are congruent. That's pretty cool. I'm gonna write it like this. I'm gonna say XZ is congruent to BY, which is also congruent to CY. That's kind of fun. So that means I'm gonna put some congruent marks on this picture. If I know BY and CY and XZ are all congruent, I'm gonna put two little congruent marks on XZ. What is XY congruent to? How many congruent marks goes on XY? 3, very good, Tilly. Because it's equal to AZ and ZC. And then what about YZ? How many congruent mark goes there? 1, very good. All right, the reason I wanted to mark up my picture is the next problem actually kind of throws us back to chapter 4. It says, are there any congruent triangles in the diagram? Are any of these triangles congruent? All of them are. Why?
Because they all have the same markings.
And what do we call that?
Side, side, side.
Side, side, side. Wow, you guys didn't forget everything over Christmas. It's been 5 weeks and you still remember some things. I'm going to say yes. All 4 are congruent by side, side, side. All 4 are congruent by side, side, side. All right, letter F says, if the perimeter of XYZ is 36, then what is the, letter E, how does the perimeter of XYZ compare to the perimeter of ABC? How do the perimeters relate? So I've got, this is one perimeter, and this is the other perimeter. Yeah, Catherine.
It's times 2, or like XYZ would be half it.
Very good. So XYZ is equal to half of the ABC, or you can think of it the other way, XYZ times 2 equals ABC. How did you know that, Catherine?
Because they have 2 all the side and side, so you multiply each of those 2.
Good. So like for each one of the inside sides we look at, there's not just one that it's congruent to on the outside, there's 2 that it's congruent to. So that means if I have like 1 length over here, I have 2 of that exact same length over here. So every side is multiplied by 2. That means all of the sides, the perimeter would be multiplied by 2. So I'm going to write this. I'm going to say P triangle XYZ. That to me is saying perimeter of. If you want to write perimeter all the way out, it's your notes. Do whatever makes you happy. And I'm going to say that equals 1/2 of perimeter of triangle ABC. Again, if you hate fractions, you can already go 2 times perimeter of triangle XYZ equals perimeter of triangle ABC. You do not need both, but whichever one makes you happy, whichever one makes the most sense to you, let's use that one. All right, we had to do E to figure out how the perimeters relate, and now we're going to look at F. It says if the perimeter of XYZ is 36, then what is the perimeter of ABC? Rosie, why? 36 equals half of triangle ABC. So if we multiply by 2 to get rid of that 1/2, we get 72. Perimeter of ABC. Awesome. Everyone feeling okay about that? No complaints? Okay. We got a few problems down here that we're going to solve. But we kind of worked through a lot of different concepts above. We reminded ourselves about perimeter. We reminded ourselves about side, 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 and triangle congruency. We talked about that the midsegment is parallel to the side opposite, and the midsegment is also 1/2 of the side opposite. So we're going to use those concepts now to actually put some numbers to it. So we didn't do a lot of numbers before. Now we're going to do some numbers. So the first example says, in the diagram below, AB is a midsegment. Okay, so this is a midsegment. Okay, team timeout. What does that mean about A and B? Tilly? Oh, I thought you knew. Ella, do you know? Oh, yeah. They're midpoints. Very good. And how do you know that? Absolutely. Midsegment is made up of midpoints. If AB is the midsegment, then that means A and B by themselves are midpoints. Okay, now we want to find the value of X. Why was it helpful that we stopped and figured out that B and A were midpoints, Rosie? Good. So we were given DB and BE. And since we know B is a midpoint, then those two segments are equal to each other. So we can set up a super simple equation, x minus 7 equals 2x minus 17, and we can solve from there. Minus x from both sides, add 17 to both sides, so I just get 10. That's what I got when I did it yesterday. Okay. Questions yet? Similar idea, but not the same math for the next one. So AB is still my midsegment. Points A and B are still my midpoints. But it looks like I gave you segment AB and segment RT. How are those two related? Catherine. Or 2 times AB equals RT, whichever one you want to write. And I love that you said it in those terms, and now we're going to put numbers with it. So we know that AB times 2, or 2 of AB, 2 times 2x plus 5, is going to equal my 3x plus 15. And then we're going to solve. Again, you could keep the 1/2 in front of the 3x plus 15, but I knew I was going to get rid of it anyway. So I'm going to get rid of it and distribute. Biggest mistake is we forget to distribute. Don't forget to share that 2 with everybody. Minus 3x, I get x. Minus 10, I get 5. Oh, perfect. So what happens often is sometimes we see the word midsegment and we automatically do like 2 times 1 segment equals the other. This is a reminder that sometimes it's just reminding us that we have a midpoint and that segments are simply congruent, not 2 times the other one. So make sure you really read the problem. Make sure you really look at the diagram before we start solving, okay? All right, let's look at the next one. It says given J is the midpoint of KL, H is the midpoint of KM. All right, before I read the rest of the problem, I'm just going to write that down and I'm going to label that on my picture. So if J is the midpoint of KL, then that means JK and JL are congruent. If H is the midpoint of KM, that also means KH and HM are congruent. X is in reference to JH, that segment JH. I know that's not super clear. If it's a quiz or a test, I will make sure it's super clear what that X refers to. X refers to the length JH. How are we going to find out what X is? Ella? Good. 2 times X equals 30 because twice that inside equals the bigger one. And so what does X equal? Awesome. All right, cool. So we're used to that. We've done that a couple times. Great job. The next one that was talking about angles. Have we talked about angles at all yet today? No. But what did I tell you about the segments? They're parallel, right? We got to go all the way back to chapter 3 and remember how parallel lines relate. It says measure of angle L is 80 degrees. So I'm going to come up here and I'm going to write 80 degrees up here for angle L. So that's like this angle right here. And I want to know what angle LJH is. LJH, that's this segment right here. What I'm going to think about is I know these two lines are parallel, right? It's been kind of a while since we've thought about parallel lines. Remember, if we have parallel lines and we cut through with a transversal, we've got a bunch of relationships now. How is angle 80 and then angle LJH, how are they related? Supplementary, because they're what? Consecutive interior. So consecutive interior angles are sup, and supplementary means that they add up to 180. Wow, you guys didn't forget everything over break. I'm so proud of you. These are consecutive interior angles. And remember, if lines are parallel, then consecutive interior angles are sup. So that means 80 plus something equals 180. So what should measure of LJH be? 100. Oh, you guys are killing it. How are you feeling? Good? Okay. Let's flip our paper over. We are going to do a little reminder, a little review of stuff that we learned for the final. Okay. All right, reminder. It says midpoint formula, slope formula, distance formula. Ooh, it's been a while since we thought about those. Who remembers one of them? Who can give me one of those? Rosie, give me one. That's slope intercept formula. I want to know, like, if I give you 2 points, how would you find slope between those points? Y's go on top. Y's go on top. No. Yeah, you said X is on top. Y2 minus Y1 over X2 minus X1. That's my slope. There we go. We found it. Who knows another one? Who knows midpoint or distance? Yeah, Catherine?
Distance is D equals
Big square root. Mm-hmm. Good. Both squared. Awesome. So big radical x2 minus x1 squared plus y2 minus y1 squared. And then last one, does anyone remember midpoint? Catherine, go ahead. Good. Add up the x's divided by 2, add up the y's divided by 2. We normally get to this section before the final, so this is usually like a good way to kind of review before the final. However, this year we didn't, so it's still a good thing to review. Midpoint and distance kind of pop up every so often, so it's nice to kind of see those. And now you should have all three at the top of your page. What we're going to do is we have to find midpoints, we have to prove that we have parallel lines, and we have to show distance. We're going to kind of take this piece by piece. I might have like girls do one problem, boys do the other, because I don't need you to do 20 midpoints or 20 distances. So just feel free and then make sure you do your part so that we can share it with the other group. So the first one says, find the coordinates N of the midpoint KM and P the midpoint of LM. Which formula do you think we should use? It says find the midpoint. Which equation should we use? Midpoint, right? Midpoint formula. That wasn't a trick question, I promise. All right, girls, why don't you do this? Girls, you find N. Find N, the midpoint of KM. Boys, you find P, the midpoint of LM. Here are the, I'll leave the points up on the board if you need to see them. I'd probably leave it in a decimal form. All right, anyone have n? Or am I moving too fast? Anyone have n? Anyone have p? Yeah, Catherine, what do you have?
For n, I have 7/2.
Perfect. 7/2, comma 2, or you could even leave it as a decimal, 3.5, comma 2. Very good. Boys, who found p for us? Adding the x's, so -2 plus 5 is 3/2. Add up the y's, -1 plus 1. That's 0. You're allowed to get 0. Sometimes we get 0, we panic, and we're like, oh my God, that can't be right. 0 is a legit answer. All right, n and p, we got those. All right, cool. Next, it says show that NP is parallel to KL. What do we know about parallel lines?
This is when like
What do you know? What's special about parallel lines? Yes, they have the same slope. So how can I know if they're parallel? Just find the slope, right? Girls, can you find the slope of NP? Boys, can you find the slope of KL? So just find the slope, y2 minus y1 divided by x2 minus x1. I'm gonna write same slope next to it in case I go home and I forget why we did this. They need the same slope. You just found the points before. So NP, we're using those points from above. Tell me, did you find your slope for KL?
Me?
Yep.
Yeah.
What'd you get? Perfect. Girls, did anyone find the slope for NP? It should be 1. Is that what you got? Good. It says show that they're parallel, so they should be the same. If you're getting the wrong answer, it should be the same. But if you do it correctly, you will get 1. So 1 for PN or NP, 1 for KL. So they both have the same slope. So that's good. Yay. All right. And then now the last one, it says show that NP is equal to 1/2 KL. What's the one formula we haven't used yet? Distance. So we're going to use distance here. So we want to find the distance of NP, and we want to do 1/2 times the distance of KL. I will write these out, but again, I just challenge you to pick one of them and practice that. Again, there's no need for us to do 2 or 3 of them. You've learned distance before. We're just reminding ourselves. So I'm going to do both of them. I know decimals might scare you, but 3.5 minus 1.5 just becomes a whole number. 2 squared is 4, 2 squared is 4, square root 8. Do you remember how to simplify radicals? Ooh, we're hitting a lot of things today. 2 and 4 and 2 and 2. Every time you see a pair, it comes out. You did NP. I got my distance to be 2√2. Go do KL now. See, K is 2, 3, and L is -2, -1. Okay. I have to remember this has to be 1/2 the distance. I'm going to do 1/2 whatever I find. So 2 minus negative 2 squared plus 3 minus negative 1 squared. 2 minus negative 2 is 4, so I've got 4 squared. 3 minus negative 1, oh, also 4, cool. 16 plus 16. All right, I get to 1/2 root 32. Can I just do 1/2 of 32 and then do the square root of it? No, you have to simplify your square root of 32 and then you can take 1/2 of anything on the outside of the radical. So if I'm going to simplify 32, I know that 4 and 8 go into 32. 4 becomes 2 and 2. 8 becomes 2 and then 4, which is 2 more 2s. Every pair you have gets to come out. So I've got 2 times 2 on the outside. So I've got 4 root 2. Ooh, but don't forget to multiply by your 1/2. And that's 2 root 2. Is that what I got for NP? Yeah, awesome. There's a lot of little solving here, but it's good to practice and good to know how to do. I promise you there's one like this on your homework, so that's why I wanted to make sure I did it all the way out. So just know we did midpoint formula, we did slope formulas and compared them, and then we did distance formulas and compared them. Okay. Who has any questions yet? All right, I think that was the hardest of what we're doing today. The next part's super easy. You guys ready for the last little bit of today? Okay, turn your paper over. I've got one more side of notes I want to do. I'm going to do this side of notes. And this is triangle inequality theorem. Need some props. All right, so I have 2 writing utensils and then a cap. You cannot just make a triangle out of any 3 segment lengths that you want. If I have these 3 segments, I can make a triangle, and I'm trying to hold it nicely so you can see. I can make a triangle out of these because if I were to put the 2 smallest ones together, they are together bigger than the 3rd one. Let's see if I have, what if I just did 2 caps instead? If I did these 2 caps and this pen, can I make a full triangle here? Will those ever touch? Oh, I don't think they will ever, ever, ever touch, no matter how much I want them to. These 2 small segments together are not bigger than the 3rd segment. So that's all I'm teaching you today. Okay. This theorem says, well, first I kind of I walked through the little experiment. Blah, blah, blah. No, it can't. The sum of the lengths of any 2 sides of the triangle must be greater than the length of the 3rd. And so the reason I said the 2 smallest sides is because, duh, a small on the largest side is obviously going to be bigger than the smallest side. But whatever your 2 smallest sides are, together they must be bigger than your biggest side. If they're not bigger than your biggest side, you will not have a triangle. If they are equal to your bigger side, you will not have a triangle. Okay? So let's see. Is it possible to draw a triangle with these? What are the 2 smallest segments here? 12 and 9. Okay, so I'm going to see if 12 plus 9 is bigger than 15. 12 plus 9, is that bigger than 15? Yep. What is it? 21. 21 is bigger than 15. We're going to say yes. You can't have a triangle in here. What about the next one? What are the 2 smallest sides of the next triangle? 7 and 16. Let's do 7 plus 16. What does that equal? 23. Is 23 bigger than 23? No, it's the same, right? And I didn't say greater than or equal to. I said greater than. This is not greater than, so this is not a triangle. You cannot make a triangle with those 3 lengths. All right, what about 9, 10, and 20? What are my two smallest sides there? 9 and 10. What's 9 plus 10? Is 19 bigger than 20? Absolutely not, right? Not a triangle. And last one, 28, 28, 28. That's fine. I'm not even going to do any math. That one's cool. No matter what, 28 plus anything is going to be bigger than 28. So that one's fine. On all of these, I checked the two smallest sides and I saw, are they bigger than the third side? Tommy, is that a question or are you good?
I'm good.
Oh, you just stretch? Okay, perfect. All right, the only other thing in this section I want to show you is what if I give you two sides and I want to see what are all the possible options for the third side, okay? So let's say I give you that one of the sides of the triangle must be 7 centimeters and the other one must be 11 centimeters, okay? We have three options. We could either have X, we'll say X is just the third length. We don't know what the third length. X could be the smallest side. So we could do X and then 7 and then 11. So a small number and then 7 and 11. That means that the two smallest sides together would have to be greater than 11, which means that X has to be greater than 4. It cannot equal 4, but it can be bigger than 4. Okay. We could have X be in the middle. It could be 7 and then a number and then 11, where X is somewhere between 7 and 11. That would look like this problem. That's not super helpful because it gives us -4. -4 can't be a length of our triangle, so we don't actually use this one. But the last one is helpful. What if my number X is the biggest side? What if 7 plus 11, the two smaller sides, must be bigger than the third side? Well, in that case, X has to be bigger or has to be smaller than 18. X has to be smaller than 18. Cannot be any bigger than 18. Okay. So based on this, it says X is greater than 4 and 18 is greater than X. So we can put that on like a little number line. We'll put that 4, we'll make this 18. X is greater than 4. How do I show greater than on a number line? Do you guys remember? Open circle, greater than, and then we're going to go to the right. And then it's 18 is greater than X. Or you can think of it as X is less than 18. Am I going to open or close on 18? Close. Oh, wait, what? Open, open. And then less than means to the left. So I'm going to go this way. Okay, shortcut for all of this. The two numbers that X must be in between come from the sum of the two numbers given to you and the difference of the two numbers given to you. Okay, so the sum, 18, was if we did 7 plus 11. So that's the sum of the two numbers. 4 came from the difference between them. 11 minus 7 is my difference. So if I give you two sides and say, what number should the third side be in between? We do the sum, we do the difference, and then we just make a little inequality of all the numbers that go from the sum to the difference. Okay, let's look at that. This one says, the measures of two sides of a triangle are given. The measure of the third side must be between what two numbers? Okay, so 9 and 15. What's the difference? What's 15 minus 9? 6. Difference is 6. What's the sum? 24. The triangle side can be anywhere between 6 to 24. It could be 7. It could be 23. It could be 19. It could be 15.7. Could it be 6? It can be bigger than 6. Could it be 24? No, it could be less than 24. So find the difference, find the sum, make an inequality. All right, similar for the next one. What's my difference between 11 and 20? What's my sum? Good. What's my inequality? They're both less than inequality. So 9 is less than x, which is less than 24. Okay. One more like this. 23 and 14. What's my difference? 9. Who waited me? Yeah. 24 was, oh, what did I say 24? 31, right? What was I thinking, Ella? Thank you for correcting me. I think I took 24 from the last problem. It's a great point. Everyone's probably so confused. Difference was 9. What about, what's the sum of 23 and 40 and 14? 37. You what? We still have 9 more minutes before the bell, but I'm almost done, and I'm gonna get you guys some time to like just wind down and work on homework. So, all right, what's my inequality? Good. Those are both less than, so less than, less than. That's okay. I know what you meant. All right, the last 5 questions are just yes or no's. Based on what we know, can those 3 side lengths work? So we already know we have 9 and 2. Can the other side be 7? Why not? 2 plus 9 or 2 plus 7 is 9. They can't equal each other. What about 8? Can it be 8? Sure. 2 plus 8 is definitely greater than 9. But 2 plus 7 was not greater than 9. What about 10? Yes, sure, why not? This time now 10 is a bigger number. So now I'm thinking, okay, 2 plus 9, is that bigger than 10? The answer is yes. See how I made a little flip there? 10 became the bigger number. So I really needed to check 2 and 9, not 2 and 10. What about 11? Can 9 and 2 and 11 all work? Why not? Good. 2 plus 9 is going to equal 11. It's not going to be greater than 11. It's going to be equal to 11. What about 14? Will 14 work? Also, no. It's 2 plus 9 is not greater than 14. Okay, if you turn your paper over, see how it says homework at the top? I'm so sorry I mixed homework in your note packet. I just like forgot. This side is your homework. This side that says homework right there, as well as the very first side of your notes that looks like this, the triangles with like the little lakes on it. No textbook problems, no nothing else. If this is confusing for you, wait 2 seconds. On Schoology, I'm about to put these 2 documents together in a PDF and you can do it there. Ella, what's up? Great question. Ella says, why did you keep switching the order? Because I started by doing 2 and the number that was newly given to me. Once I got to 10 though, 10 is the biggest number of the 3. So I want to always check the 2 smallest numbers. So once I was given 10, 2 and 10 were not the 2 smallest and 9 was the biggest. We had to flip it around and I needed to do 2 and 9 because 10 was the biggest number. Great question. Any other questions? All right, I know I squeezed a lot in your brain today, so now I'm going to give you the last, 10, 11 minutes of class to work on your homework / to decompress. This is due next time I see you, which I believe is Thursday. All right, and Caroline, you're free to stick around if you want, or you can head out, whatever you want.